It has to be that everything that you use currently, every single tool, just works without any change. There shouldn't be anything specific. Right? We'll get a little bit more into it, but long story short, first, long story short, it's just basically if you use Ethereum, that's it. Everything should work. Now, to the motivation of this particular talk is, one, I want to provide some clarity on the basics on what's actually going on, not just the EVM, but also a little bit on DeFi chain side. What is the current design? Why is it that we do some of the things the way we do? And then making sense out of some of the narratives that are out there. There are quite a lot of narratives. Is it, is it a Bitcoin fork? Is it DeFi on Bitcoin? Is it, for Bitcoin? What is all that about? We'll kind of touch on that a bit, and then the foundations of how we're doing EVM on DeFi chain. All right. And also, please kind of feel free to interrupt me and ask questions as well, because it's going to be, I am going to touch on the higher level topics, but we'll get in as we need. Right. So now, before we jump into DeFi chain, let's kind of start with a little bit of context, right? Everybody here is aware of blockchain on some way, right? But how do you think about blockchains? I think I should be able to point out to anybody, and then anybody should be able to answer, because everybody's in a crypto company, a blockchain company, right? Anybody who wants to kind of explain how do they see blockchains? Because banks, do you see them as banks? Do you see them as ledgers? Like, there are different perspectives different people might have, right? So anybody want to kind of talk about how they see blockchain? How do you make sense out of all of it? Shared Google Sheets. Okay. Yeah, that's a nice perspective. Anybody else? Okay, no other perspective in a crypto company. Come on, guys. Public database. Okay, append-only public database. I think that's a really good one. Right? So, okay, cool. All right. So I'm just going to share a bit of how I see blockchains as. The way I see it is, it's a series of walls on the cloud. Right? It's similar to how if it's a bank, you put your money into the bank, right? And then how the bank handles it, you have no clue. It could be a paper where it's an account for all that you care, where it's being plussed and minuses. It could happen in a computer. It could be a Google Sheet in a bank. How they manage it, you have no idea. Or they could have a huge safe, right? So the governments might have certain protocols, whatnot, but how they do it is not super transparent, except for some basic standards that they have to follow. Blockchains, the way I see it, it's like a bank locker, but it's all on the cloud. It's visible to everybody. Everybody can see all of these bank lockers, but you hold the key to it. You lose your key, you lose your funds, right? But at the end of the day, that's all there is. If you have access to a key, you can go access what's in it, you can spend it, right? So the kind of reason that I'm talking about it is, next month, I'm once EVM basics and all are launched, I am planning on going back to India and meet my 94-year-old grandfather. Every time I meet him, I see a lot of Indians in the room here. Can anybody guess what is his first question going to be? Savings. All right. So pretty much every time I meet him, his first question is, how much cash do you have? Right? It's not bank, it's not money, it's how much cash do you have? Now, the reason that he kind of asked that is, I usually defend it with, why do I have to have cash? We live in this digital age. I kind of keep my money, in banks and whatnot. But he's like, no. You need to hold cash. I'm like, that's the most inefficient way to have it. You don't get returns on it. You're basically, losing it to inflation. Like, why the heck would I do it? Well, turns out he's a smarter man than I am. No question there. But the fact is, history sort of repeats itself, right? So the reason I'm mentioning it is, no, I don't hold everything in cash, and I'm not suggesting that. But the thing is, perspectives, right? So people are almost always going to have these perspectives where there is a good chunk of people to whom cash is as important, right? And those perspectives are not going to change. And there is continuous sort of validation where, these cycles happen. right? Today, yeah. So just before an hour ago, I was just pulling out, to an AI, hey, give me a image of a bank falling down, and I want to put a specific name on it. For whatever reason, it doesn't put the name that I ask. But long story short, cash to some people holds value, and those are also, we'll connect this to blockchains in some way. But just throwing the idea of cash out there, if you were to create something like this, how would we model that in a digital world, right? So cash, at the end of the day, if I have something, I have it. If I don't have it, I don't have it. It's really simple, right? And then if I give something to you, you can return me back something else. If there is if I need to spend $20 for something, I give you 100, you give me back 80, right? Like, that's it. And what I have is all that I can spend. And there is no question of double spending and whatnot. I can't give something to you and then I can't give the same thing to somebody else because it's no longer with me, right? So the simplest way to model that is, well, let's say I have $5. I want to give $1 to somebody. I give $1 to somebody. And then like 3.9 because the person might, have a commission or whatnot. And then they might give me back 3.9. But then I can take that 3.9 and then spend it, right? So this is exactly what Bitcoin did. Bitcoin tried to model cash in with that similarity as possible, right? And in a fancy land in Bitcoin, it's called as UTXOs, right? So that's basically, at the end of the day, what that is. It's a UTXO. But for all practical purposes, you can think about it as cash, just hot, cold cash. And UTXO, of course, all of you here should know about it. It's unspent transaction outputs, right? Output basically just referring to that output. So now, this is as close as you can get to cash, but just sort of jumping back on what kind of worlds sort of exist, a little bit more context into the blockchain land. You have UTXOs, sort of similar to what we saw. And then there are so many other blockchains which kind of work on the account system. Account system, the key difference is, yes, it's same model as Bitcoin, where it's a series of vaults. But it's, at the end of the day, it's all managed by a ledger in some way. Anybody can add to that ledger, subtract to that ledger. This does not have the same principle as a vault. Because for some reason, somebody could fudge with the ledger in a different way, then your money sort of disappears, right? It could pop in out of thin air, could pop out. There's no way to, all of that. Now there are different ways to protect it. That's what Ethereum does. It's what chains like Ethereum do. But at the end of the day, it's actually that simple. This is very similar to a cash model. And as such, UTXOs, you need to provide it an input in order for you to spend it. There, it's a whole different system. And then, it's connected to the whole, world mutation and whatnot, world state. So it's built for a different purpose. This is built for a different purpose. The reason I'm talking about it is, this is still important to a lot of people. And Bitcoin does this, and it does it very well. Nothing else models this as closely as Bitcoin. Right? Ethereum has a lot of utility, but it's built for a very different purpose. Right? You can go write incredible smart contracts there, which does a lot of different things. It's built for a very different purpose. Right? So now, if you take this smart contract concept a little bit more, your expectation of Ethereum would be something like this, right? So I hold a key to this, and that's it. Only I have access to it. My funds, nothing else will ever happen. But in practice, the reality is more like it's a shared vault rather than individual series of vaults that you have it. The moment smart contracts comes into play, if you start putting your money into something associated with a smart contract, your security is only as good as their security, right? And this is not something that you have control over. And that's the reason that you would see so many different exploits now and then, right? You can still do this, but then you're not really utilizing the system, right? But if you start using that system, then it's like a group set of vaults where your vulnerability is now shared into the systems in which you participate, right? So now that's the sort of account system. Okay, why am I talking about all this? Let's sort of step back to DeFiChain, right? So DeFiChain, I think all of these are sort of narratives that's sort of going on. Is it a fork of Bitcoin? Let people here should know the answer. Let's start with the first one. Is it a fork of Bitcoin? Okay, Ben is showing thumbs up. What does a thumbs up mean? Okay, yes. So it is a fork of Bitcoin. Is it DeFi built? Is DeFi built on Bitcoin? Is that what DeFiChain is? Is it DeFi built on Bitcoin? Anybody? No. Okay. Is there anybody else who want to call that as a yes? I think we used that narrative for a while. But in any case, it's DeFi built on Bitcoin. I think the answer is a little bit more complicated, but in general, yes, I do agree with that answer. It's not built on Bitcoin because we forked it and then we built it. But we can still, it's a matter of perspective at the end of the day, right? Because you've built on the same Bitcoin code, you could potentially claim it. But from a pure technical perspective, yes, I think the clear answer is no. Is it DeFi for Bitcoin? Anybody on that? More context to the question. I don't know. What would you think about it? It's an open question. Yeah, that's a good perspective. Yes. So I think, again, the reason that I'm sort of posting this is because of the same thing. It is a matter of perspective, right? So the answer to me is maybe, right? If you consider it as, okay, can you take it off the Bitcoin chain and then do DeFi on it and then provide it back? If you take that perspective, that's a maybe. It could be. Is it a side chain? Again, I think the answer is sort of maybe, because Stacks is another one, which they also claim some of these things, but it's a clear side chain where they kind of do it and then provide it back. The reason it could be here is because we do anchor back, but anchoring at the end of the day, it's sort of, you can think about it as some sort of settlement, but then you can also say we're not putting the actual data on it. So it is, again, sort of maybe, right? Is it an L1? The answer is yes. Does it aim to compete with Bitcoin? I would say no. It's more towards connecting them and then providing the best of both worlds, right? So we'll see more on how we're sort of doing that. Okay, coming into, what DeFiChain today, it is a combination of both of those accounts and UTXOs that we saw. The idea is people who are connected to that cash system, they still have exactly the benefits of it and every philosophy that Bitcoin carries. And Bitcoin carries that philosophy like no other, right? So people who have worked with me know that in terms of the technical code base, I'm not a big fan of Bitcoin's code base and how the technically it was done. But philosophically, every single idea that Bitcoin brought in, like none of the other blockchains has today, right? It is closer to cash, and the amount of thought that was put into it, which is why the white paper was incredibly as well regarded as it is, right? So we sort of take that. It's DeFiChain is built on UTXOs, which is, yes, I have something, and then I want to give you something, then you give me something back in return, which I can end up using again, right? But then how does the DeFi part work? So now, DeFiChain, UTXOs, and I'm also going to, sort of haze over some of the technical concepts, but if somebody has any questions, feel free to stop me, and then, we'll go in. But long story short, you have UTXOs, and that part of unspent, like the previous one that we saw, some of that goes to the commission as a cashier, right? So that ends up as minor fees to the person who ends up mining the block. So UTXO, also because you provide your input, specifically, basically you sending your cash, for a validation of the block, the system can now verify that it is from you, right? Because you are the only one who holds that key for that particular vault. So we can do the TX validation as a part of UTXO, and all this, great. Now in DeFiChain, we also have accounts. How account system is also basically what works with tokens, pool pairs, vaults. So it's a combination of what both Bitcoin as well as Ethereum side has. But now, how does all of this accounts work with UTXO would be the next kind of key question, right? Because when you're working in account land, let's say we do a pool swap transaction, right? Something as simple as pool swap. So you have account with a key. Now you will do a pool swap, and then you will want that back in the exact same address, right? If it's a UTX, and the moment you start with something, you have now spent that input, right? So now it's a brand new input. You've taken away that cash and somebody else has given you a different set of cash. There is no way to identify this output. It could be the same, right? But then there is no clear way to associate that this now belongs to the exact same person, right? So we can sort of go back and design UTXOs, some part of it, to actually have all of these properties, but it's also a lot more incredibly complicated as we implement more and more of the systems. But the way the solution that we sort of implemented here was, okay, how do you do it? Now, first, if you already have the key in your wallet, right? If you have that key in your wallet, you can provide that input directly as a part of UTXO. And now UTXO would know, okay, so that is actually from you. So I can validate this as a part of the regular Bitcoin transaction validation. And great, everything else works, right? What if in my wallet, I have that key, but that key does not have DFI, so I cannot use that as input? Anybody? Anybody on then how do we actually make a pool swap transaction happen? It happens today, right? So you might not have DFI in that exact same address, but you need that address in order to validate that it's actually you spending it, right? Without that, there's no way for the system to validate. Does anybody know how we do it? Nobody? Okay. All right. So, sorry. Yeah. So there it is. I mean, that's the man who implemented it, so who designed it. So, all right. So the way we do it is it's called AutoAuth. AutoAuth basically is nothing but it goes through your wallets. If you have, let's say in your wallet, you might have K2, K3, K4, K5. And now what you want is you want an input from K1 in order for you to spend it, right? An input that is spendable with that key K1. So what the node does is it creates a transaction called AutoAuth that's basically taking from this and then splitting it, and it sends some of it to K1 and then the others back to you, right? So this is also the reason why sometimes things are painfully slow, because what the node is doing behind the scenes is actually doing two transactions. So it's executing this transaction, which is AutoAuth. So it spreads your UTXO around to the address that you want to use. And then once that block gets mined, is only in the next block can it now use that transaction. So it needs to wait for that and then use that transaction input, and then it follows the rest of the flow, right? So this is all done automatically on the node, and then if you use Ocean on that architecture as well, all of this is automatically done. So the reason that you don't know it is a good thing, because it's an underlying detail that as a user you shouldn't be using it, but internally this is basically what happens. So now talking about AutoAuth, now so basically that's the larger picture of it. So once the account with key 1 is sort of created, now it sort of comes back, right? You use that as input, and then everything else is exactly the same. Okay, now we have EVM, right? So with EVM, you might have something like MetaMask that is doing all of this. So here, AutoAuth, the node understands what all of your UTXOs are. Basically, at the end of the day, Bitcoin node, any nodes with UTXO, it has it tracks every single unspent transaction, right? So it's like a real-world equivalent of every cash that's out there that is spendable, that is a live index of it. So it matches it. It's like, okay, great. This is something that you have, then I can use it. MetaMask or anything on the Ethereum side has no concept of UTXOs, right? So it doesn't know any of that. MetaMask, if you use it, you will have your own key. Now then, how do you run a transaction on DeFiChain without that knowledge, right? So this sort of becomes one of the key challenges, because as we sort of go back to why I was making that really poorly attempted joke on that everything about EVM, and that's the end of the talk, is the reason is the designing philosophy, again, is it has to work with every single existing tool, right? So how do we accomplish it without MetaMask having no knowledge of it? So now to get into that, let's sort of look at BTC transactions, right? BTC transaction has a bunch of different things, but the key thing that we'll focus on is it's the TX in, TX out. TX in is the transaction that you want to spend, and then TX out is what comes out. Now, this is a standard transaction, and there is a special transaction in Bitcoin, which is also what happens in DeFi chain, which is transaction in is, it's technically null, but for all practical purposes, you can consider it as zero, right? There is this one special case transaction, that is the Coinbase transaction. And what Coinbase transaction is used for is usually, it is a transaction that's mined by the miner itself. So it's not something that people explicitly send. It's accumulation of the block, and then the miner adds this transaction. So there is no need for verification on that. And then that's also where the transaction where the miner fees gets paid out, right? So all the fees gets accumulated, and then it's passed on to that address of the miner. So this Coinbase, we kind of took that Coinbase concept, and then, so signature validation sort of happens over the TX in. And so Coinbase, there's nothing to be validated. Bingo, cool. And DeFi chain, we introduced a new transaction called XVM. So what that transaction basically looks like is very similar to this. It takes that Coinbase concept, zero input. It's also zero output. The output technically can be pay the fees as well, but we'll sort of come back to why we don't do that. Both of these are output. Everything is set to zero, and then the entire EVM transaction is sort of stuffed into the data. And then what we do, so now the system kind of understands this. This is a special case transaction where it will not do the validation, that signature validation, because it has nothing to validate here. And the reason that we're able to sort of get away with that is, well, EVM does all of its own validation, right? So it is something that it's good at because it knows how to validate the EVM transaction better than anybody else. So, well, we don't really have to do anything. All we do is we just pass it straight up along. So EVM takes care of that each signature validation, and that takes care of the validation part, but this is now validated as in a similar land to how EVM is. Now you don't, the whole cash methodology where, if you have it, you own it, and then you spent it, it's gone. That principle doesn't apply here anymore, right? But that's fine because EVM does its own, it has its own set of securities, right? So, and then we pass it along to EVM, and now EVM can do it. So when MetaMask, you pass it through, this is kind of the transaction, how it's going to show up. All right, let's sort of jump out. Just zooming out now, the DeFiChain block. The DeFiChain block is going to have, a whole bunch of your regular UTXO transaction, which is what every Bitcoin one has. And then you will have these special transactions, which are these XVM. It's just going to be interspersed like any other transaction, except, there's going to be no inputs, no outputs. And as it sees it, regular ones, BTC, DFI style transactions, there's a regular validation, and then only then it goes in. This one, it sees that the current DeFi chain system doesn't know how to interpret it. It passes it along to the subsystem, and that subsystem theoretically could be anything. It's EVM today. It could be any other VM as well. So we are abstracting that concept. Today, you can sort of replace XVM with EVM because that's a specific one that we're doing. So it does the validation and then sort of comes back. This is basically what the block is going to look like, right? So now, sort of jumping back out, if we do that, if this is just enough, it'll work. Everything EVM works, but then going back to all of the tooling, MetaMask, all of that will not know how to interpret any of this, right? So it doesn't know how to deal with UTXO transactions. So what do? We kind of have a synthetic block. It's not a real block that exists on DeFiChain block, but all of the Ethereum RPCs expects an Ethereum style block. So we'll construct a synthetic block there, and then each of those synthetic blocks will have fully formed EVM TXs. So any RPC that you call regarding the Ethereum side, it's going to receive that. It's going to look like an Ethereum block for that tooling perspective. So all of the current existing Ethereum tools just work because they will not need to know about that. They will just look at that block and then great, whatever is interpreted there, they can work with that, right? So this system also works because let's say if I have UTXO and then, I pass this along, I pass an UTXO along here, now I lose the concept of that UTXO security, right? It all gets sort of intermingled. So the reason this all still works without that is we've now created a clear barrier of separation. So your UTXO cannot directly go in, right? So just come back, fees. Before that, yes. So how do we do fees here is the next question because this has nothing, right? So miner needs fees. So basically fees are also delegated to the internal system and then it's accumulated and then brought all the way back up. and it gets added along as a part of the regular block. But this fee is paid in tokens and not UTXO. So now today, DeFiChain Block will just pay UTXO, but not tokens. Previously I sort of mentioned, like why not do the fee here, right? As a part of this zero. We can still bring that back and then provide it here. Does anybody know why we don't do it? Sorry? Incentivization. That's a good thought process. But the thing is, we're sort of forcing it out at the moment. So anybody who runs it, EVM is a part of it, right? So that is a good thought process if it was optional, right? But that's not the reason why we can't just emit the fees here. If you emit the fees here, it would actually be even clearer. It just becomes every other system, right? It's like every other transaction. There's an output, and then that just goes off to the miner. Okay, so the reason we don't do that is, now if you do it here, it has to be UTXO. It'll be a token there. You'll be killing off a token on Ethereum side because Ethereum has no knowledge of UTXO. And then suddenly you will be sprinting UTXO here and then providing that as the output, which is still fine. But the problem is now accounting all of this becomes so hard. And not just EVM, now particularly if you have other VMs as well, and if you want to design it that way, you need a clear one mechanism where you can track how everything goes in and then track how everything comes back out. So that is the reason that now we're sort of decided, okay, we won't return it as UTXO. Rather, we'll just, okay, let's sort of come back to it. And then we'll sort of provide the fees as tokens. Now, a little bit more in depth on fees. This is a part that, it's not actually done yet, and it's probably not going to be a part of the first iteration of DeFiChain EVM. But long story short, how it's going to work is it's going to be an XVM fee scaler. Today, Ethereum, every opcode fees are scaled differently. But then, your overall system is based on the network. On DeFiChain land, how we're going to approach it is, again, each of the opcodes can be assigned a particular weight. And there's also DeFiChain opcodes, which will have a much lower fees. And then all of this, we already have a very good governance managed attribute system, right? So, well, why not just delegate all of that? So now you actually have knobs that you can tweak, right? Because these are systems now. The whole philosophy is we'll design the system as something that we can learn and then evolve as we need it, right? It's not going to be a fixed system, but you're going to have certain knobs where if you see that, okay, a fees of a certain particular transaction is being misused or, if certain aspects are being overused, then the community will still have a model where they can tweak knobs so that the whole ecosystem never sort of crashes. That's the idea behind having this particular scaler. And it's going to just use, same set of attributes. So we can, the way to do it is just adjust the weights of how you deal with it and then subsidize some of the old EVM, so old DeFiChain transactions. So the philosophy behind it is, you should still be able to use it on some level, right? So if you don't want to use the whole EVM feature set, but because of EVM, the fees are rising, then you will still be able to get your transactions across as long as you rely on the native aspects of the chain and not the EVM aspects of the chain. So again, it's not something that even we have thought through in detail, but it's just a general idea of how to approach it as we build it. So that's kind of the basics on fee structure, sort of coming back to the larger domains of all of this. UTXOs, DeFiChain, everything that you see today operates on DeFi accounts and token system. And then you're going to have another, which is the new one, which is accounts underneath it. So all of these are going to be clearly separated boundaries. And because they are clearly separated boundaries, so in fact, accounts and EVM, from a technical point of view, it even made sense to just unify them. Then we just move one of the systems to the other, and then that's it. We can call it a day. But we decided not to do that. The reason being to have this physical boundary where, if you want to, and that boundary, because of that boundary is the reason that you have that clear accounting on what comes in, what goes out of the ecosystem. So people who are concerned about, hey, I want to retain the cash nature of it. I came to the ecosystem because of UTXOs. I don't want to lose it, right? Because DeFi building DeFi on top of or for Bitcoin is the narrative that people have come into the ecosystem for, right? So we want to continue to preserve that. So people who want to do that, just do UTXO. If you are concerned about it, if you don't want to be exposed to that smart contract world, keep it as UTXOs. Token system right now, it's going to play a sort of a little bit of a dual role, but then EVM is going to be completely separate. Now, talking about domains, now you need a clear way to sort of cross between these domains, right? So that's where something called transfer balance TX. This is one TX and this is going to be the only methodology for you to move beyond all of these domains. So all domains are going to be completely separated out. If you were to take something out from here, move something, it needs to be an actual transaction, which is that transfer balance transaction. And if you want to see what's coming out of the ecosystem, moving out of a particular domain in the ecosystem, so transfer balance should be able to plus and minus it. It gives you the clear accounting layer across all of them. And Ethereum accounts, by the way, the node now fully supports Ethereum addresses. So along with the regular addresses, you can have Ethereum addresses, and that separation of boundary is also the Ethereum address. So on DeFiChain node, now you'll have 0x addresses, and anything that you move there goes into the EVM account system, right? So that's sort of crossing of domains. That's crossing of domains today. And crossing of domains, how it's going to look like a little bit down the line is, so I sort of mentioned something called DVM. So DVM, the idea is it's a DeFiChain VM that we use today. But today, it uses the auto-auth mechanism. So it relies on all of the regular validation flow, which is also why you need 2 transactions instead of 1. So now that we have enabled this capability to have no inputs and then use that, why not just reuse that for DeFiChain native transactions as well, right? So then we can sort of abstract everything out as DeFiChain VM is now just another VM. So the signature validation happens inside instead of outside. And then, so you have UTXO, which is going to be 100% compatible with how exactly Bitcoin works. And that's going to be continued forward. So that is the cash system. And all of these account systems are going to sort of come into this one blob where DVM is just another VM, right? EVM is another VM. And then Z is just for the lack of a letter. That's something else where we can integrate. But the DVM is going to have more of a special set of things that it can do, right? Which is basically the transfer balance is going to be a part of DVM. So anybody who wants to sort of move across these ecosystems, they will use the transfer balance in DVM to move. DVM is also what's going to have all the other stuff that we have today, like a DEX that you can sort of rely on the chain itself for, and not just projects on these individual VMs. And then governance models, which kind of controls the whole sort of ecosystem, right? So we'll continue to build on that, move that into DVM. And that's kind of the next aspect on domains. That's the big map. Anybody know why that's empty? It's a landscape for you all to, think about. No, I'm just kidding. I didn't have time for it. So, this was supposed to be the large technical map that I sort of shared with the others before, but I'll throw it out of the channel once it's complete. But this is going into more in detail about particular aspects of there's several different components. What we use EVM, what is the VM that we actually use, which is Sputnik, and then how all of these sort of come together, and how we are also moving APIs towards Proto and whatnot. But it's probably another whole tech talk. So yeah, this I will share a little bit later the channel. And coming back to today, so MetaMask should be usable. You can connect to it on developer network. It is up and running. I think it's sort of broken, but you can still connect to it. But long story short, what I want to sort of say is here, the ops, the usual flow is going to be exactly the same thing. How you use EVM, just spin up DeFi as usual. BTC tools will point to the big old RPC port. The DeFiChain VM tools, same RPC port. All the EVM tools will point to the new EVM RPC port. That's it. And this sort of, comes back to the very second slide of mine. No, actually, I added more. Okay, sorry about that. That's pretty much it. That should end the EVM part of it. And MetaMask, is Shoham here? Okay, he's not. Oh, hey, do we have an IP? Maybe we can sort of just demo people how you can connect to it. All right, so just pull me the IP that we have, and then once I'm done with it, I'll come back. So that's now, and then sort of just going back to touching on MetaChain. What is MetaChain? That's the other larger story. MetaChain is sort of something where we can take the VM concept even further, not just VMs in chain, we also connect with other chains, right? So that is sort of, the MetaChain story is still, the narrative is still being, it's being, everybody is sort of still brainstorming on it and what exactly it's going to be. But for the time being, the way that we're operating is, that is something that will connect all of these chains together, which opens up a lot more possibilities. Again, it's not a talk about that, but just wanted to mention it so that people have an idea on what that is. So where we are today on that larger journey is where we already have native, and then we're going to have EVM, which is the part that we're working on. Then the cross-chain protocol is the one that completes that larger story. That's probably something for another day. So we'll not get into it, but yep, that should be it at the end of the day. Thanks, everyone. Questions? Any questions?
So how many transactions can be packed in one XVM transaction? So how many EVM compatible transactions we can pack in one XVM transaction of a block in the new chain?
Sounds good. So it's a one-to-one. It's exactly one. So it's just another transaction. So if you have an EVM transaction, it's going to be turned into an XVM transaction on the block, on the regular DeFiChain block, but it represents one transaction. So it's, as a part of the block, it's not just EVM, right? So you have some other transaction, it's going to be a direct one-on-one map, and the fees for that transaction is going to be deducted the exact same way. And it's also, we are preserving that transaction to transaction like mapping ability. We're not going to change that. Is that up? All right, good question. The whole block right now, I think it's somewhere around, so because Bitcoin has these a little bit more complex mechanisms on whether it's segued or not. So I think it is somewhere around, at the moment, our parameters are sitting at close to 8 megabytes, something like that, on the overall block. And then specific transactions, there is no consensus level aspect which is applied, but there is a miner policy. So the miner policy can be tweaked, as every miner individually can. I think that sort of limits it to something like 2 megabytes, if I'm not wrong. I don't know the specifics, but I can check into it. Yeah. The overall one is, it's a Bitcoin limit for, if it is a SegWit transaction where the signature is actually, much smaller. So that'll be, I think, a little bit, somewhere closer to 4 or 8, I don't recall. Something like that. And the legacy transactions, but I mean, we do use SegWit for everything now. The previous ones were, I think, somewhere around like 1 to 2 MB or something like that.
We can have a couple of in a single block of
Yep, exactly. It's just going to be similar to how you do it on Ethereum. Just like how Ethereum block is going to have a bunch of transactions. It's just that there's going to be a synthetic mapping and you're going to have a different block construct. But at the end of the day, it's just going to be another regular transaction that's going in. All right. Anything else? Yep.
Yeah, just wondering on is it EVM equivalent here or is it EVM compatible? And then in the sense if it's equivalent, can I just use all the EVM stacks, for example? I have a node, EVM node, I just make a node and implement all the RPC calls, and it works out of the box, and I can just fork all the everything on EVM, like Uniswap or all the dexes, and just fork it here and just deploy without changing a line of Solidity code there.
Yep. Fantastic question. So the question is, hey, can I just take any code from Ethereum blockchain and then just deploy it, and if it just works, right? Yes, that is the goal. So that's the reason that we've sort of had this synthetic block construct and all of that. So to every application there, you just throw it out, as long as it has all its dependencies as well, right? So if it depends on, for instance, another smart contract address, then obviously you'll need that smart contract address as well. So, but yes, just pull older, open source versions of Uniswap or any other swap, take it, deploy it here, it should ideally just work. That's the goal. If it isn't, yes, that's probably something that we need to fix. So please go ahead, try it. If it's not working, reach out to us, and then we'll have to fix it. That being said, currently it's a little bit broken, so maybe not try that in the next week, a little bit later after that. All right. Anything else? Was there another question there? Yeah.
So for the EVM gas fees, is it going to be in DFI? And then how we're going to deduct the fee from the user DFI account? Yeah.
Excellent question. So I'll sort of go back to the slide on the fees here, right? So very simple answer is, yeah. So we don't do anything regarding fees here, right? So it gets passed on to the VM. And here, as far as EVM is concerned, EVM on DeFi chain, the native token is DFI, right? So DFI is the one that's going to be used for fees everywhere. So here on EVM side, the fees is calculated for each of these transactions. How it's calculated was the other one. Right now for testnet, we're basically just going to set it as something like 0 or a tiny fixed amount. So you have it here. The system accumulates that fee, and then that fee sort of comes back into the block. But it's all DFI. So the current fees for UTXOs, you pay it in UTXO, but this one, it's particularly is in token. Yeah, so this is the other internals on how the scaling is kind of going to work. Very rough structure. EVM internally, the way it deals with it, every opcode has a particular weight. Right? So based on that weight is how your particular contract's fees are calculated. So the same methodology here, EVM is going to, once it's on mainnet, the same methodology is going to apply all of those weights. The weights are something that we'll define here. And then the DeFiChain opcodes that we insert in later. Today, we don't have, EVM is its own island, but later on, we'll have capabilities to reach out into the DVM opcodes, which it's going to be present. DVM features are going to be presented as DVM opcodes into EVM. So it's just going to be another opcode in EVM where you can say, access the DeFiChain DEX, right? You can say, hey, swap this token in the DeFiChain DEX for me, right? So that opcode will take your DeFiChain tokens on EVM land or representations of it. It could be an ERC20 representation, and then take it, do the swap, and then provide it back to you. So these will be scaled very differently. The idea is to keep this much lower. So anything on the native side, it's so much easier on the DeFiChain land to reach into. And then all of that goes into this, fee weights. So the fee weights, how we set it, we can use them as knobs where using governance system, we can control all of those fee weights. So it's actually not going to be fixed like on EVM, like on Ethereum blockchain, for instance, right? So these are something we can dynamically tweak as well, depending on, now I have no idea how we are going to use it, right? But the philosophy is we sort of build it in a manner where we can evolve from the learnings, right? And it's not like you need to do a hard fork after that, right, to be able to do it, but because we do have a robust governance system, right? So since we have it, why not just use it? So all of those variables there, the fee kind of goes into that weight calculation, and then this is the fee for a particular transaction, right? So each transaction goes through the same cycle, you get the fee, and then that fee overall for EVM side gets accumulated, or rather for, if you abstract it, an EVM, right? An EVM, that's a subsystem, accumulates the fee, passes it back to the miner on the actual DeFiChain block, and then the actual DeFiChain block will distribute those fees as tokens. So anything a part of UTXO will be given as UTXO fees. Anything that's not, anything takes this additional XVM path will be paid in tokens, DFI tokens. All right, anything else? Nice, I too had, this is nice having questions. Anything more? Okay, great. So everybody knows how EVM works. Cool. All right. Thank you, everyone. Thank you so much. Appreciate it. And rest of the stuff I'll follow. We'll add more details. Thanks.
Thank you so much, Prasanna. Very, very nice presentation. I thoroughly enjoyed it. Thank you, everyone, for coming. Please clean up after yourselves. And yeah, hoping to do this many times more. Thanks.